We've talked about graphing quadratics in vertex form. Now we're going to talk about another form of quadratics called intercept form. And in intercept form, you are going to be able to figure out the 2x intercepts or 1x intercept right away from the information that was given to us. So the forms here, y equals a, and a does the same thing as it's done in the other on the other functions and the other forms, but we have this x minus p times x minus q. What this means is that one x-intercept will be p comma 0, and the other one will be q comma 0. So you take the opposite of what you would see, because that minus sign will make it change. Now we have to talk about how to get the axis of symmetry and the vertex. The axis of symmetry will be exactly in between, or halfway in between, the two x-intercepts. Because if we have our two x-intercepts here, half the distance from one and half the distance from the other, that will get you at the middle, because our parabolas are symmetrical. So you will need to know the x-coordinate of the vertex is halfway between the x-intercepts. You could use the formula p plus q over 2. That will give you the x-coordinate of it. I find that most students will just plot the two x-intercepts and then find that in between. Well, once you find the axis of symmetry, that's also the x-coordinate of the vertex. So to get the y-coordinate of the vertex, you can plug in your axis of symmetry. Plugging in. Okay. So then that would give us a third point, because we have our two x-intercepts, we have the vertex, and then you want to pick another number, preferably a small number and a number easy to work with, to find out another point on our parabola, and then we're going to reflect that. So let x equal different values, substitute that number into the equation, and then you're going to reflect this point across the axis of symmetry. And again, the graph opens up and has a min if a is positive, or it opens downwards, and that means it has a max if a is negative. We don't need those areas. It's positive or negative. So let's look at this problem here. First thing I want to do is find out our x-intercepts. So it's going to be the opposite of this minus or negative 1. So it's going to be it's going to be 1 comma 0. And then here we see x minus 5 is going to be 5 comma 0. So there are the x-intercepts. Now to find your axis of symmetry, we want to go halfway in between. So 1, 2, 3, 4. Halfway in between is right here. This is our axis of symmetry at x equals 3. And again, you could have done 1 plus 5 over 2, and that still would have given you 3. Now we need to take that 3 and plug it into our original function. So you could do this in your head, or you could do it in the calculator, or you could write it out. You get y equals positive 8. So the y-coordinate of the vertex is 8. The x-coordinate was 3, so our vertex will be at 3 comma 8. So we can write that down here. 3, 8. Axis symmetry was x equals 3. This has a maximum value at y equals 8. We saw that up here. Now, to figure out that other point, I said pick an easy point. And once you have these 3 points drawn, then it becomes easier to figure out. Like, we don't want to pick x equals 0 because you may think that's an easy point to figure out, but if you follow the curve of this graph, it's going to be way down here. The y value would be. So what I would do is I would pick a point in this area, an x value in this area between your vertex and your x-intercept. So I'm going to pick x equals 2. So x equals 2. And then plug that in. 2 minus 1 times 2 minus 5. Okay, let me fix that. Y equals negative 2 times 2 minus 1 is 1. 2 minus 3 is negative 3. So we get positive 6. 1, 2, 3, 4, 5, 6. There we go. And then we can reflect that over the axis of symmetry. So this point is 1 unit away from the axis of symmetry. We can go 1 unit on the other side, and there would be our point. So then here is our parabola. And now we can answer the domain, range, and end behavior. Domain is always going to be negative infinity, comma infinity for these quadratic functions. Range, our y value, our parabola is open downward, so that means the smallest y value is negative infinity, and the largest one will be our y coordinate of the vertex. In this case, it is 8. So range negative infinity, comma 8. And behavior, as x approaches negative infinity, y is also approaching negative infinity. And as x approaches infinity, y is approaching negative infinity because our parabola is opened downward. So graphing in intercept form is not as difficult as vertex form. There's not as much math as you're doing, but you do need to make sure you have 5 points. Now, on the next page here, we're going to graph this one. Your x-intercepts, negative 3, comma 0, because it's the opposite, and negative 5, comma 0. So then the x-coordinate of your vertex is going to be exactly in the middle. Here's our axis of symmetry at x equals negative 4. And then we're going to plug that into our equation here. So y equals 3 times negative 4 plus 3 times negative 4 plus 5. And if we type that into the calculator, that is going to give us, let's see, 3, negative 1. That will give us negative 3. So here is our vertex. So negative 4, comma negative 3. We also can see from our graph that that is going to be a minimum value right here. So it's a minimum is at y equals negative 3. Now we need that other point. And I said last time, pick a point between your x-intercept and your vertex. Oh, we don't have a nice number in this area. So let's just go one outside. Let's go at x equals negative 2. Let's do x equals negative 2. So y equals 3. Negative 2 plus 3 times negative 2 plus 5. And I'll type I'll throw this one into the calculator so you can see how that is done. So 3 parentheses, -2 plus 3, and -2 plus 5. And we get 9. So 1, 2, 3, 4, 5, 6, 7, 8. It'll be up here. And then we reflect that over. We're 2 away from the axis symmetry, so we get 2 over. It would be there. Now that we have our graph domain, since this graph is opened upwards, we are going to start with the smallest y value, which is -3. We go all the way to infinity. And with the end behavior, as x approaches -infinity, the y values are going up. As x approaches positive infinity, the y values are going up as well. So again, these problems are a little bit quicker to do once you get those points down. All right, this next one, I'm going to have you guys try after we talk about the x-intercepts. Is this one? This would be 4, 0, no problem. But what about this right here, this -x? Well, let's just look at the x. It would not make sense to write this x minus 0, because anything minus 0 is just what we started with. 5 minus 0 is 5. 12 minus 0 is 12. X minus 0 is just x. So when you see just an x out front, that means one of your intercepts is 0, 0. That negative that negative attached to it, that means your a value is -1. Okay, so now that I have given you the x-intercepts, pause the video, try this problem, and then we'll talk about it once you're done, and you can check your work. All right, here you go. You can look at your answers. So for this one, I picked x equals 1 for my other point and then reflected that over. Again, you could have picked other points. I try to keep the points I pick as close to the axis of symmetry or the vertex as I can. So that's why I went with that value there. Okay. So I hope that you got most of these or all of this correct, or if you didn't, you can see where you made that mistake.